Find the cost, average cost, and marginal cost at a production level of 1,000 units. So we have our C of Q equation right here. So if we are given C of Q and we're looking for the cost of 1,000 units, then that means that we're looking for where our Q value is 1,000. So if we substitute in our 1,000, that's our Q, that's our number of units, into our cost equation that we're given, we can solve that down, and it looks like we get 342,491.12. So whatever this item is that you're producing, to produce 1,000 units of it costs about $342,491. So now we're looking for the average cost. Well, average cost means that you take your cost function and you divide it by the number that you're making. So this is our average. Well, we can do that. We have our capital C of Q, our cost function, figured out to be 342,491.12. And we know that we're making 1,000 units. So divide that by 1,000. So if we're essentially spreading this cost over 1,000 different units, then we're looking at a cost of $342.49 about per unit. So then we're trying to find our marginal cost. Well, our marginal cost is our derivative of our cost function. So we have our original cost function. We need to take its derivative. The derivative of 16,000 is 0. The derivative of 200Q is just 200. And the derivative of 4Q to the 3 halves, bring down your power. 4 times 3 would be 12, divided by 2. So it's going to look like 4 times 3 over 2. So 4 times 3 is 12, divided by 2 is 6. And then subtract 1. So if we have 3 halves minus 1, that's really minus 2 over 2. So that gives us 1/2. So our marginal cost at 1,000 units, so we replace Q with 1,000, would be 200 plus 6 times 1,000 raised to the 1/2. And then if we type all that into our calculator, we get 389.74. So now it's asking us to find the production level that will minimize the average cost. Well, minimizing the average cost, well, let's see if we can figure out our average cost equation first. So we know that average cost is equal to C of Q, and that is our cost equation divided by our quantity. Well, we are given our cost equation at the top here. So if we want C of Q, then that is big C of Q divided by Q. But we know that big C of Q in this case is 16,000 plus 200Q plus 4Q to the 3 halves. There we go. So now we need to divide everything by Q. So if we divide 16,000 by Q, that'll look like 16,000 Q to the negative 1. 200Q divided by Q is 200. And 4Q to the 3 halves divided by Q is 4Q to the 1/2. There we go. Now we're trying to minimize. So whenever you're trying to minimize something, you take the derivative and you set it equal to 0, remember. So we want to take our derivative. So the derivative here would be bring down your power. So negative 16,000 Q subtract 1. So it becomes the negative 2. The derivative of 200 is just 0. It's a constant. And our derivative here, bring down your power. 4 times 1/2 is 2. And subtract 1. So now we have our derivative. Now, if we want to minimize, we take our derivative and we set it equal to 0. So 0 equals negative 16,000 Q to the negative 2 plus 2Q to the negative 1/2. So we can rewrite this if you don't like looking at it this way. Another way to write this would be to consider our q to the negative 2 as q squared in the denominator. And then q to the negative 1/2 would be like the square root of q. So if you prefer to think of it this way, totally fine. It means the same thing. The solution process will be very, very similar. One benefit of putting it like this is when we move the minus 16,000 over q to the second to the other side by adding that whole term, we can cross multiply. Because we have the fractions here, we can cross multiply, which will give us 16,000 times the square root of q equaling to q squared. And then we're trying to get q by itself. So if we divide both sides by the square root of q, well, let's do the 2 first. Let me get rid of the 2 first, and then I'll do the square root of q. So if we divide both sides by 2, we'll have 8,000 times the square root of q is equal to q squared. I need to have the q's all on the same side. So if we think about this as being divided by the square root of q and divided by the square root of q, then this is going to look like q to the second, which is 2 for our exponent, q to the square root, so minus 1/2. So if we put this in terms of halves, this would be 4 halves. 4 halves minus 1/2 is 3 halves. So q to the second divided by the square root of q is q to the 3 halves. So that's going to leave us right here with 8,000 is equal to q to the 3 halves. So what that means is we need to take the 2/3 root of both sides. You know how if you have a square root, you square it, a third root, you take it to the third. So what we need to do is multiply by the 2/3 power and multiply by the 2/3 power. And when we do that, we will get 8,000 raised to the 2/3. I'm going to go this way because I'm almost out of space, is 400. And that's going to equal q. Now, in this case, we only got one critical number. So we only got our critical number of 400. So putting 400 in, that's what's going to minimize our production. If we are trying to maximize, well, think about it. The more you produce, the more it's going to cost. So maximizing our production wouldn't make sense here for this situation because we could always just produce another and then it would have a little bit higher production cost. So it looks like the production level that's going to minimize would be 400 units.